Okay, everybody, can you see on the screen? Pause. Okay, this topic is very important. This is the basic topic in physics. Okay, because we can learn a lot more about force. So please make sure you pay attention to this topic. Force. Okay, first of all, we need to know what is force. Look at the definition. This is actually the definition of force. Can you read together? Okay, good. That's very simple definition. Can you memorize this definition? Push or a pull? Very easy. Okay. Okay, so we look at this diagram or photo. In the first photo, what do you see? Pulling. Okay, you open a can, you pull the lid. And then the next one, push the switch, right? Okay, so that are examples of force. Okay, very simple. Okay, we are going to do this experiment later. But first, we need to learn about force. Okay, type of forces. Okay, this is something that you need to know. Okay, what is the first one? Gravitational force is the force that points towards the earth of the earth. This force causes all objects that are thrown upwards to fall back to earth. Okay, at your level, gravity is known as a force. Okay, but when you learn further, maybe when you go to university, you will find that gravity is not a force. Okay, but at your level, gravity is considered a force. Okay, you know why? Why scientists later found out that gravity is not a force? You know why? Huh? Magnetic. What? Okay. When you refer back to the definition, gravity is a push or a pull, right? So let's say you have an object here, okay, and then I release it, it falls, right? Do you see something pulls it? Do you see something push it? Okay, there's nothing push or there's no pull here, but it moves. But people in the past thought that it was a force. Okay, so that's why at the beginning, at your level, gravity is known as a force. But later you will find out gravity is not a force. But I'm not going to confuse you at the moment. We just learn what is written there in the textbook. Okay, so be patient. You're going to learn that later, especially when you go to university. Okay, the next thing is frictional force. Okay, frictional force is the force that resists movement between two surfaces that are in contact with each other. This is very common in our life, right? When you push a trolley, for example, at a supermarket, right? You feel the resistance? You feel the resistance when you push the trolley in the market? Okay, that is frictional force. That is something common in our life. The next thing is buoyant force. Right, you can see the duck toy there is floating. Did you have an experience where you try to lift a rock from the bottom of a river? When you pull it, you find it not very heavy. As once the rock is out of water, you find it heavy. Did you have that kind of experience? Okay, why you find it less heavy when it's in water? Because we have buoyant force. Okay, because we have buoyant force. The next thing is elastic force. Okay, you can see the diagram. Elastic force. Okay, hold on. I cannot answer that. Okay, next. Okay, the next thing is weight. Okay, weight is defined as gravitational force. This is what we discussed now. Actually, Weight and gravitational force actually is the same thing. Okay, weight is gravitational force also. Okay, the next thing is a normal force. Normal force. What is normal force? Let's say you have an object here. Okay, you have an object. Then you put it on the table. Okay, you put it here. Do you find that this object moves down? Move down to the floor? No, it remains here. So why it remains here? Because what? Okay, it has weight, right? Okay, but what is the force mean here? There is another force given by this table upward. This table is giving another force upward against gravity in opposite direction, but the same magnitude. Okay. For example, let's say that uh, the weight of this apple is 3 Newton, for example, 3 Newton. Okay, this is the weight. W stands for weight. But this table is giving another force upward, also 3 Newton in opposite direction. Opposite direction, but the same magnitude of force. Understand? So this is what we call normal force. Okay, we call it normal force. What else? Okay, that are the forces stated here. Okay, the next thing, characteristic of force. Force is a vector quantity. Okay, remember this is a vector quantity. You know what is vector quantity? Vector quantity. So when we say vector quantity, it has both magnitude and direction. Magnitude and direction. Because when you push something, is there any direction? It moves, of course, because the direction is same as the movement of the object. Most of the time, it is the same as the movement of the object. Understand or not? You have an object here, and then you push it. Is there any direction? Yes, there is direction. Can you give me an example that quantity that does not have direction? For example, what? Okay, let me give you one example. Temperature. Temperature. It has value, it has magnitude, but it doesn't have direction. Can you see the difference now? Okay. So force is a vector quantity because it has both magnitude and direction. Okay. For example, this box is pushed, right? And the magnitude is 10 Newton. And then what is this? Hammer. Okay, hammer. You pull the nail out. So it has direction also. And it has magnitude. Okay. Actually, you can read all this yourself, but we're going to discuss it generally like that. Okay, measurement of force. How are we going to measure force? Okay, we use spring balance. Spring balance. Okay, look here. Spring balance. Okay, this one you can look at it yourself when we do the experiment later. Okay, unit of force. Unit of force. The SI unit of force is what? Newton. Newton comes from what? Comes from where? Isaac Newton, correct. Newton comes from a scientist in the past whose name is Newton. So he used his name as a unit, okay, as a remembrance of his contribution to physics, okay. The next thing we're going to see, the weight of an object is the gravitational force acting on the object on Earth. Remember here, on Earth. Pay attention here, on Earth. We are considering on Earth, not on another planet. On Earth, an object with mass of 100 grams 100 grams has a weight of 1 Newton. Therefore, an object with a mass of 1 kilogram has a weight of 10 Newton. Okay, remember, many students confuse this. This is actually mass. This is not weight. Most of the time we say 1 kilogram is weight, right? Actually, this is not weight, it is mass. But 10 Newton here, this is weight. And the actual unit for weight is Newton, not mass. Understand or not? Please remember what I'm saying here. Okay, one more time. This is mass. This is mass, not weight. And you can see here, the sign arrow is used. It is not using the symbol of equal. Why? Why equal is not used here? Because the unit is different. So just same as when you want to compare length and temperature. Temperature and length, they are two different quantities. You cannot make them equal. They are different. So the same thing as this one. 1 kilogram is a mass, 10 Newton is a weight, so you can use symbol equal. They are only equivalent. Okay? Equivalent. But one more thing, let me tell you, this is not accurate actually. But at your level, we accept this. Actually, how we're going to relate this? Actually, the formula to relate this, but this is only for information. You don't have to worry about this. Okay, you're going to learn this later. Actually, the formula which relates mass and weight is W equals mg. Okay, this is the formula that relates weight. This is weight, and this is mass. Okay, G here approximately 10. G approximately is 10. That's why when you have 1 kilogram multiplied by 10, you get 10. So 1 kilogram is 10 Newton. But let me tell you that this value 10 here is only approximation. The actual value is 9.81. This is the actual value. Okay, but don't worry about this. This is only for information. I just want to make it clear where how you relate 1 kilogram and 10 Newton. But at your level now, we accept this. Yes. SPM we use only 9.1. Nanti cikgu akan beritahu lagi lah bila belajar ni ya. Untuk peringkat awak tu pakai 10. We follow textbook. Okay, how you going to measure weight? So you just hang the object on the spring balance. We call this spring balance. Hang the object. How do you know frictional force? Just pull the object horizontally like this. So we'll be able to know what is the frictional force. Get it? Good. Okay, the next thing is action-reaction pair. So this is the one that I have discussed just now, but we are going to look at it again. Observe the object in photograph 8.1. Why do these objects remain stationary? You can see the car there. It remains stationary, right? It is not moving downward or it is not moving upward. Why? What are the forces acting on these objects? You can see the apple here, apple and the book. They are also stationary. Okay. Look here. Third Newton law. Okay, Newton proposed 3 laws. First Newton law, second Newton law, and third Newton law. But now, the it goes straight. Third Newton law. You want to know what is third Newton law? Third Newton's law states that for every action there is reaction. Okay, every action there is reaction. Force of the same magnitude, but opposite direction. Did I mention about this just now? Still remember? Okay, good. Okay, can you explain to me again? We have a book on the table. Is there any force acting on this object? Can you tell me what are the forces? The first one, this is what? This one. This, what force is this? What force? This is weight. Okay, this is the weight. What is this force? Normal force. They have the same what? Same magnitude, but opposite direction. That's why they are stationary. That's why the book is stationary. Okay, the next thing. The next situation, an object that floats on water. Floats on water. Okay, the wooden block that floats on water experiences a gravitational force known as weight. Okay, so see here we have an object, and here is the weight. The weight is the force acting downward, and then we have what is this? Buoyant force. Buoyant force is actually a reaction force, opposite direction. The same thing here. It has the same what? The same magnitude. Direction here on the buoyant force, it has the same magnitude but opposite direction on condition that the object must be floating. But if the object is sinking, that is different story. Can you tell me, if the object is sinking, which one is bigger? Buoyant force or weight? Weight, okay, good. But if the object is rising, buoyant force will be greater than the weight. But if it is floating, it should be the same. Okay. The next thing is two trolleys. Okay. Two trolleys is in contact with each other and launched with a spring mechanism. Will move at the same distance but in opposite direction. Now you have the trolley, first trolley and second trolley. And can you see the spring here? The spring is compressed. When we release the spring will expand again. It will expand to its original shape. That's why this trolley will push each other and will move against each other or in opposite direction. Okay, action and reaction.